Preparing for a technical interviews at TCS interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the 4 pillars of object-oriented programming, and how have you used them? The 4 pillars are encapsulation, abstraction, inheritance, and polymorphism. I use encapsulation to protect state, abstraction to expose only necessary behavior, inheritance for genuine as a relationships, and polymorphism to substitute implementations behind a common interface. For example, a payment service can call different gateway implementations without changing business logic. I also prefer composition when relationships are flexible, because it reduces tight coupling and fragile class hierarchies. While answering, define encapsulation, abstraction, inheritance, and polymorphism. Connect each to maintainability, reuse, and flexibility. Include a practical project example and mention when composition is preferable to inheritance. Question 2. How would you find duplicate elements in an array efficiently? I would scan the array once while maintaining a hash set. For each value, I check whether it already exists. If it does, I report it as a duplicate, otherwise I insert it. This gives O(n) average time and O(n) extra space. If modifying the input is acceptable, sorting reduces auxiliary space to O(1), excluding sorting overhead, but changes ordering. I choose based on memory constraints and whether duplicates must be returned once or repeatedly. Make sure to cover the hash set approach, time and space complexity, sorting as an alternative, constraints involving value ranges, and why a nested loop solution is usually unsuitable for large inputs. Question 3. Explain the difference between a stack and a queue with practical use cases. A stack follows last in, first out ordering, while a queue follows first in, first out ordering. Stack operations include push and pop, making it useful for recursion, browser history, expression evaluation, and undo functionality. Queues use enqueue and dequeue, supporting task scheduling, buffering, and breadth-first search. With array-backed implementations, I ensure queue removal occurs at the front efficiently, typically using a circular buffer or linked structure rather than shifting elements. In your answer, distinguish LIFO from FIFO behavior, describe core operations and complexities, and provide suitable examples such as recursion or undo for stacks and scheduling or breadth-first search for queues. Question 4. What is the difference between an array and a linked list, and when would you choose each? Arrays store elements contiguously, so indexed access is O(1), and cache performance is strong. Inserting or deleting from the middle usually costs O(n). Linked lists store nodes connected by pointers. Access is O(n), but insertion can be O(1) after locating the position. I choose arrays for frequent reads and predictable memory, and linked lists when structural changes dominate. In practice, dynamic arrays are often preferable because their locality improves real performance. Be sure to mention contiguous memory, random access, insertion and deletion costs, memory overhead, cache locality, and how workload characteristics determine the appropriate data structure. Question 5. How does binary search work, and what conditions are required for it? Binary search repeatedly compares the target with the middle element of a sorted collection. If the target is smaller, I discard the right half, otherwise, I discard the left half. The search finishes in O, log n, time and O(1), iterative space. I maintain clear inclusive or exclusive boundaries consistently and calculate the midpoint as left plus half of the difference to avoid overflow. Sorting is required unless another ordered structure is available. Focus on sorted input, maintaining valid left and right boundaries, midpoint calculation, logarithmic complexity, duplicate handling, and avoiding integer overflow in midpoint computation. Question 6. What is recursion, and how would you prevent excessive stack usage? Recursion solves a problem by reducing it to smaller instances of itself, with a base case that stops execution. Each call consumes stack space, so incorrect termination or deep input can cause overflow. For factorial, I can use a clear base case, but for large linear depth I would convert the logic to iteration. In overlapping problems such as Fibonacci, memoization avoids repeated work. I always analyze both time complexity and maximum recursion depth. In your answer, explain base and recursive cases, call stack behavior, termination, tail recursion, iterative conversion, memoization, and the risks of stack overflow for deep or unbalanced inputs. Question 7. What is the difference between a process and a thread? A process is an independent program instance with its own address space and resources. Threads are execution paths within a process and share its memory. Processes provide stronger isolation, but communication is more expensive. Threads are lightweight and useful for concurrent tasks, though shared data introduces race conditions. I use locks, atomic operations, or message passing where appropriate. Multiple threads may run in parallel on multiple cores, while concurrency can also occur through time slicing. Make sure to cover memory isolation, resource ownership, context switching, communication, concurrency, parallelism, synchronization, and why threads can improve responsiveness while increasing shared state risks. Question 8. What is deadlock, and how can an operating system or application prevent it? Deadlock occurs when tasks wait indefinitely for resources held by one another. It requires mutual exclusion, hold and wait, no preemption, and circular wait. I prevent it by acquiring locks in a consistent global order, keeping critical sections short, and using timeouts where suitable. Systems may also detect cycles and recover by terminating or rolling back work. Avoiding shared mutable state or using higher-level concurrency utilities often reduces the risk significantly. Discuss the 4 necessary conditions, including mutual exclusion and circular wait. Explain prevention, avoidance, detection, recovery, lock ordering, timeouts, and practical synchronization discipline. Question 9. What is normalization in a relational database, and why is it important? Normalization organizes relational data to reduce duplication and prevent insert, update, and delete anomalies. First normal form requires atomic values, second removes partial dependency on a composite key, and third removes transitive dependency. For example, I would separate customer information from order records rather than repeat it for every order. Normalization improves consistency, but I may denormalize carefully for read-heavy workloads, documenting the integrity and synchronization trade-offs. While answering, explain reducing redundancy, functional dependencies, update anomalies, and common normal forms. Also mention that selective denormalization can improve read performance when justified by workload. Question 10. How would you optimize a slow SQL query? I begin by reproducing the issue and inspecting the execution plan rather than guessing. I check for full scans, inefficient joins, missing or unused indexes, excessive rows, and unnecessary columns. Then I improve predicates, add an appropriate composite index, rewrite expensive logic, or replace offset pagination when necessary. I benchmark before and after with realistic data, because an index can accelerate reads while increasing write cost and storage usage. Be sure to cover execution plans, indexes, selective filtering, joins, projections, statistics, pagination, avoiding functions on indexed columns, and validating improvements with realistic data and measurements. Question 11. What is the difference between primary keys and foreign keys? A primary key uniquely identifies each row in its table and cannot be null. A foreign key references a key in another table, representing a relationship and enforcing referential integrity. For example, an orders table can reference customer ID from customers. I decide whether deletes should cascade, restrict, or set null based on business rules. Foreign key indexes often improve joins and deletion checks, although the exact choice depends on database behavior and workload. In your answer, define uniqueness and entity identification for primary keys, relationship enforcement for foreign keys, nullability considerations, referential actions, indexing, and their role in database integrity. Question 12. Explain the difference between get, post, put, patch, and delete in REST APIs. Get retrieves a resource and should be safe and idempotent. Post commonly creates a subordinate resource or triggers an operation and is not inherently idempotent. Put replaces a resource and is generally idempotent, while patch applies partial updates. Delete removes a resource and is typically idempotent. I return meaningful status codes, validate input, design predictable resource URLs, and use idempotency keys when clients may safely retry creation requests. Focus on HTTP semantics, safety, idempotency, resource modeling, request bodies, status codes, validation, and why consistent API behavior matters for clients, retries, and maintainability. Question 13. What is the difference between authentication and authorization? Authentication verifies who a user or service is. Authorization determines what that identity may access. A login might authenticate through a password or multi-factor method, then issue a short-lived token. The API validates that token and checks roles or scopes before allowing an operation. I apply least privilege, hash passwords with a strong adaptive algorithm, protect tokens, enforce expiration, and never treat authentication alone as permission to perform every action. Make sure to distinguish identity verification from permission checking. Discuss passwords, tokens, roles, scopes, least privilege, expiration, secure storage, and how both controls work together in an API. Question 14. What is exception handling, and how should it be used in production code? Exception handling separates expected failure paths from normal business logic. I catch specific exceptions at boundaries where I can recover or translate them, preserve the root cause, and guarantee cleanup with finally or resource management constructs. Logs should include correlation context without exposing secrets, while clients receive safe, consistent error responses. I avoid empty catch blocks and broad catches that mask defects. Retries belong only around transient failures and should use limits or backoff. Discuss predictable error handling, specific exception types, cleanup, logging context, user-safe responses, propagation boundaries, retries, and why exceptions should not silently hide defects or replace normal control flow. Question 15. What are the main principles of software testing, and how would you test a new feature? I start with unit tests for business rules because they are fast and isolated, then add integration tests for databases, APIs, or messaging. Finally, targeted end-to-end tests validate critical user journeys. For a new feature, I cover normal, boundary, invalid, authorization, and failure cases, using mocks only where isolation adds value. High coverage is useful but not sufficient. Assertions must verify behavior. Automated tests run in C before merging and deployment. In your answer, cover unit, integration, system, and regression testing, boundary cases, mocks, testability, automation, negative scenarios, coverage limitations, and the testing pyramid. Question 16. What is Git, and how do you resolve a merge conflict? Git records project history and enables parallel development through branches. When a conflict occurs, I first understand the intent of both changes, inspect the marked sections, and manually combine the correct behavior rather than choosing blindly. I remove conflict markers, run relevant tests, review the diff, and commit the resolution. I reduce conflicts by keeping branches current, making focused commits, communicating ownership, and avoiding unrelated formatting changes. Be sure to mention version control, branches, commits, pull requests, conflict causes, reviewing both changes, testing after resolution, and safe collaboration practices such as small focused commits. Question 17. How would you design a simple URL shortener? I would expose a create endpoint accepting a long URL and return a short code, then redirect requests for that code. A database stores code, destination, creation time, and optional expiration. I can generate codes from a sequence encoded in base 62 or use random values with collision checks. Since reads dominate, I would cache popular mappings and replicate storage. Rate limits, malware checks, analytics, and predictable expiration policies address operational and security concerns. Focus on API design, unique identifier generation, storage schema, redirects, collision handling, scalability, caching, expiration, abuse prevention, and metrics for reads, writes, and failed lookups. Question 18. What is cloud computing, and what are IaaS, PaaS, and SaaS? Cloud computing provides on-demand computing resources over a network with elastic capacity and usage-based pricing. IaaS offers virtual machines, storage, and networking. PaaS manages the runtime and deployment platform. SaaS delivers a complete application to users. For a web service, I might choose PaaS to reduce operational work, while IaaS gives deeper control. I still evaluate security, availability zones, vendor dependence, monitoring, and total cost rather than assuming cloud is automatically cheaper. While answering, define on-demand shared resources, elasticity, and measured usage. Distinguish infrastructure, platform, and software services. Include responsibility boundaries, availability, cost, and a practical deployment example. Question 19. What is the difference between compile time and runtime errors? Compile time errors are detected before a program runs, such as syntax mistakes, type mismatches, or missing symbols. Runtime errors occur during execution, including division by zero, null access, unavailable files, or invalid user input. I address compile time issues through compiler feedback, static analysis, and tests, while runtime risks require validation, defensive handling, logging, and monitoring. Strong typing catches many defects early, but external data must still be validated at runtime. In your answer, distinguish errors detected before execution from failures during execution. Provide examples, explain debugging approaches, and mention that static checks improve reliability but cannot replace runtime validation. Question 20. Describe a technical project you completed and the challenges you faced. In my project, I built a task management API with a relational database and token-based authentication. I owned schema design, service endpoints, validation, and deployment. The main challenge was preventing inconsistent updates, so I introduced transactions and integration tests around concurrent changes. I also added indexing after reviewing query plans. The result was faster filtered searches and more reliable updates. This project taught me to measure performance, document trade-offs, and design security from the beginning. Make sure to structure the response with problem, role, architecture, decisions, challenges, measurable outcome, testing, and lessons learned. Emphasize personal contribution rather than only describing the team. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.